So the second part of this measures of disease lecture is on measures of association between exposure and disease. And I'm going to be talking about the prevalence ratio, the odds ratio, risk ratio, and rate ratio. So what do we mean by an exposure? You've already heard about this in this course. So anything that may potentially be associated with an outcome of interest, we refer to often as an exposure. Usually it would be an attribute of an individual, such as years of education, their body mass index, their cholesterol level, prevalence, their presence of antibodies to hepatitis C virus, for example. But it could be something environmental, like local air pollution level. So the first definition here is the prevalence ratio, the relative prevalence. Increasingly commonly used. The prevalence ratio is the ratio of the prevalence of disease in one group to that in a comparator group. So it's simply the prevalence of disease in those with the exposure divided by the prevalence of disease in those without the exposure. A ratio of 1 indicates no association between exposure and disease. So in this example, the prevalence that we're talking about is not for a disease, but it's for a self-reported risk behavior, self-reported recent high-risk condomless sex in HIV positive men who have sex with men. And the exposure we're interested in is recreational drug use. So we have a group of men who reported not using recreational drugs, of which there's 1,110, and of these 39 reported higher risk sex. So therefore a prevalence of higher risk sex reported of 3.5%. Reporting recreational drug use were 1,138 men, and of those 117 reported higher risk sex. So the prevalence there was 10.3%. So the prevalence ratio for men reporting recreational drug use compared with men not reporting it, the prevalence of higher risk sex was 2.9. And we can calculate a 95% confidence interval for that. So this is just to note that these measures like prevalence and prevalence ratio are not only used for studying presence of disease, they're also used for things like high risk sex, where that's the attribute of interest here. The next measure of association is the odds ratio, or often called the relative odds. The odds ratio is the ratio of the odds of disease in one group to that in a comparator group. And so this is defined essentially in the same way. Odds of disease in those with the exposure divided by odds of disease in those without the exposure. But actually, in the case of the odds ratio, you can also express it as the odds of exposure in those with disease divided by the odds of exposure in those without disease. It's the same thing. A ratio of 1 indicates no association between exposure and disease. So let's look at an example. And this is a case control study done in northwestern China of the association between esophageal cancer and higher vegetable intake. So for a group of people with esophageal cancer and a control group without esophageal cancer, they asked about vegetable intake per day. And they divided people up according to whether they were in the cases or the controls for esophageal cancer, and then whether their vegetable intake was above or below this cutoff of 520 grams a day. And so they formed what we would call a 2-by-2 table here. And then if you look across the rows, you see in those with the lower vegetable intake, the odds of cancer is 190 over 127. Remember that the odds is the number of people with the disease divided by the number of people without the disease. And then in the second row, those with vegetable intake greater than 520 grams, the odds of cancer is 169 over 253. So we have the two odds, and now we want the ratio of the odds. And so you can see in the box there, you calculate the ratio of the odds in those with the exposure, which is high vegetable intake, divided by the odds in those without the exposure, low vegetable intake. And you can see the calculation there, it comes to 0.45. So the 0.45 the odds of esophageal cancer in people who had high vegetable intake. Now remember that I said that you could also look at this the other way around. And so if you look down the columns and you look at those without esophageal cancer, the controls, and you look at the odds of having high vegetable intake, that's 253 divided by 127, and then you do the same thing for those with esophageal cancer. You look down that column, you get the odds of high vegetable intake. And if you work out the ratio of the odds of high vegetable intake by presence of cancer, the odds ratio, you come to the same number. So the odds ratio is the same either way around, as I mentioned on the previous slide. So the next measure of association is the risk ratio, or the relative risk. The risk ratio is the ratio of the risk of disease in one group to that in a comparator group. So this is exactly the same concept. So the risk ratio is the risk of disease in those with the exposure divided by the risk of disease in those without the exposure. Ratio of 1 again indicates no association between exposure and disease. So to illustrate the risk ratio, let me return to the study which addressed the question which I asked you in part 1. So this was a randomized controlled trial of pre-exposure prophylaxis to prevent HIV infection in men who have sex with men. So men were randomized to either receive these two antiretroviral drugs, tenofovir and FTC, or to receive a placebo for those drugs. I've already shown you that for those in the placebo arm, 1,248 HIV negative men initially, 64 became infected with HIV. HIV infection was the event. The risk of the event was 5.1%. In those on the drug, the active drugs, 1,251 men followed over time, 36 became infected with HIV. So the risk in that group was 2.9%. So the risk ratio, in this case the exposure that we're considering is active drug. So those with the exposure, those taking active drug had a risk of 2.9%. Those without the exposure, those on placebo, had a risk of 5.1%. We divide one by the other to get 0.56. And then we have a 95% confidence interval that can be calculated for that. And you can see that that doesn't overlap 1. And so we have good evidence that the active drug did reduce the risk of HIV infection in people taking it. And we now know from subsequent studies that the effect of such pre-exposure prophylaxis is a very large effect and approaching over 90% protection for people who are adherent to taking PrEP to prevent HIV infection. And just to show you from this paper, the group presented Kaplan-Meier estimates, which I told you about in part 1, and they showed the Kaplan-Meier estimate of the cumulative risk of having HIV infection for those in the placebo group and those in the group who took PrEP, FTC, tenofovir. So you'll remember the question I asked you in part 1. If an HIV negative person takes antiretroviral drugs, can this make them less likely to acquire HIV when having condomless sex with an HIV positive person? The answer is yes, much more likely. So just a word on interpreting risk ratios. If a risk ratio is below 1, showing a reduction in risk compared with the comparator, we often calculate the percent risk reduction. So the percent risk reduction is 1 minus the risk ratio times 100%. So we had a relative risk of acquiring HIV in men on PrEP of 0.56. So the percent risk reduction is 44% risk reduction. The percent reduction can also be calculated for prevalence ratios, risk ratios, and odds ratios. Note that the percent risk reduction is sometimes called the relative risk reduction. Now, if a risk ratio is above 1, we might refer to a percent risk increase. So the percent risk increase is defined as the risk ratio minus 1 times 100%. So for example, if the estimated relative risk of stroke in people who smoke 1 cigarette per day compared with no cigarettes is 1.74, then the percent risk increase is 1.74 minus 1 times 100%. It's a 74% risk increase. And the percent risk increase can also be calculated for prevalence ratios, rate ratios, and odds ratios. So the next measure of association is the rate ratio or relative rate. And this is exactly the same sort of concept. The rate ratio is the ratio of the rate in those with an exposure to that in a comparator group without the exposure. So it's the rate in those with the exposure divided by the rate in those without the exposure. So for example, a rate ratio of death of 2 for smokers compared with non-smokers means that smokers have twice the rate of death as non-smokers. A ratio of 1 again indicates no association between exposure and disease. So let's look at an example of the rate ratio. So this comes back to one of the questions I asked you in part 1. So this was a randomized trial in which partners, HIV negative partners of people with HIV, were randomized to have the partner with HIV initiate antiretroviral treatment immediately, or for that partner not to initiate antiretroviral treatment immediately. So the HIV incidence rate in the HIV negative people, if the HIV positive partner was not initially started on ART, so this is the control group, was 1.7 per 100 person years. The HIV incidence rate in HIV negative people in the group where their partner started immediately on ART was 0.06 per 100 person years. So the rate ratio for those with the exposure having a partner with antiretroviral treatment divided by those without the exposure, partner not initially on antiretroviral treatment, the rate ratio was 0.04 with a 95% confidence interval that didn't overlap 1. So this showed, for the first time, this early study showed that if people are on antiretroviral treatment, they have a lower risk of passing on HIV compared with if they're not on antiretroviral treatment. And we subsequently know that if a person's on antiretroviral treatment and their HIV viral load in their plasma is below 200 copies per mil, there is no risk of passing on HIV through condomless sex. So the answer to the question, if a person with HIV is successfully treated, does this affect how likely they are to transmit HIV if they're having condomless sex with an HIV negative person? The answer is yes, much less likely to transmit. So an overview of what you've learned. This session has set out many of the basic elements of epidemiologic research which can be used as a basis for building your understanding of epidemiology of specific diseases and of more advanced epidemiological concepts. We come back to risks, rates, odds and the ratio measures in the remaining Year 1 DDS sessions.